any pushback. That's really been widely appreciated by the public, that they can go on a site and get an unbiased readout of what's going on. You can go to any sewer shed in the state and look at where we are compared to the entire pandemic up till date. One of the nice things is the health department also got detailed geographical data on all of the sewer sheds that they can combine with all of the patient data they get. So when there is a patient in the state, they can ping it to a certain sewer shed. So we know very well how many patients were diagnosed in each sewer shed, which was really helpful in the beginning when we were trying to figure out whether this works or not. What we did is we would just take a period of time and we would count up the total amount of RNA, of SARS-CoV-2 RNA that was in each sewer shed, and we compared that with the total number of patients that were logged in that sewer shed, and it formed a straight line. And actually it got to be really useful, not only to validate that this was working, but whenever there was a point that didn't fit in the line, if it seemed like there was too much or too little, we could usually go in and figure out why. And I could give a whole other seminar just talking about the weird stories of finding out what kind of weird shit was happening that caused the numbers from a sewer shed to be off. But it's a really good reflection in almost every case of what's going on in the population. But it's not static. And I want to take a minute on this slide to explain it. So this is, you can look at this. This is on our dashboard. This is all of the numbers, the cumulative numbers since the beginning. So the orange line is the cumulative wastewater numbers week to week since the beginning. The blue bar graphs are the total number of diagnosed cases, and the yellow is the number of cases specifically in our sewer sheds that are covered by wastewater surveillance. And so whether you look at the entire state or just our sewer sheds, they very much mimic each other. But what I want you to notice is how in the first wave, there was this big difference. We saw way more, a lot of RNA compared to the number of cases compared to what we saw later. So this was sort of the original wave when we came out of lockdown. And then we had this second wave, which was Delta. And you realize this RNA was not that much higher, but then came the Omicron wave, and now they were about even. And then with each wave, the amount of RNA that we got per diagnosed case seems to be going down. And I think that's actually what's happening, is that when you have less wastewater signal per diagnosed case, it either means there's less RNA per infection or there's more cases being diagnosed. And I don't think the cases were really diagnosis was going up that much. I think it's that, as people were getting vaccinated or getting their second or third infection, the amount of RNA that was being shed per case was reducing, which is what you'd expect, actually. And that continued to go on with every wave until about the beginning of this year, as was mentioned, when we once again decided that the pandemic was over and we basically stopped testing, it reversed again. So now we're back to where we were before, where there's way more RNA we're detecting than the actually diagnosed case. But I'm sure that this is because there's no cases are being diagnosed. So I think a lot of groups, fairly think that wastewater and hospitalization records are probably the most reliable ways of knowing what's really going on with the virus at this point. So now I know that was a short part. That was part one. That was just basic wastewater surveillance. Part two is about, well, what else can we learn? So starting in late 2022, we decided to, someone raised their hand. Should I answer questions now? No. Okay, I'll keep going unless someone says otherwise.
Keep going.
Okay, so about 6 months into it, we decided maybe we could get some more information about the virus than just how much is there. And at that point, there was really no established protocols for sequencing a virus from wastewater. So we kind of developed our own. So what we do is actually a little different than most groups. So I knew from studying, I'm a virologist by training. What'd I just do? I knew from as a virologist that the virus mutates in a fairly predictable way, that the virus has a part of its spike protein that is what binds to the host cell receptor ACE2, and that's how it enters the cell. And this little blib right there, this is literally the sequence. This is the amino acid sequence of that part of the protein. And what happens is, because that's what binds to the cell, if an antibody binds there, it neutralizes. It prevents the virus from infecting. And that's what a neutralizing antibody is. Those are the good ones that can block an infection. But what happens is then the virus will start to pick up mutations like this one, which is E484K, which was a really popular one early on. It's in a part of the spike where a lot of antibodies bind. And what happens then, if it picks up that mutation, the antibody can't bind anymore. And then this is called an escape mutation, which means that it's escaped from certain antibodies. And because this one part of the spike is where most of the neutralizing antibodies bind, this is where there's a really strong selective pressure to pick up these mutations to adapt. And so this gives us an opportunity for identification, because it basically is like facial recognition. If we can figure out what the sequence is of this part of the protein, we know what lineages are circulating. And so our strategy was to try and not sequence the whole genome, but to focus on these little pieces where which are information rich, and just sequence those. So we do it in such a way that we sequence the whole area as one continuous string, so that we not only know what mutations are there, but we know which mutations went together. Because if you have 100 different samples, they're not all going to be the same, and you want to know which mutations go together, because that's what will tell you what the lineages are. And it's been really successful. This is our output from the state on, what lineages were circulating, simply based on wastewater. And it's basically, you could superimpose it on what you learn from patient sequencing. It is a very, very good reflection. And so this is my cheat sheet, or at least this was my cheat sheet. We've gotten some new ones now, but so each one of these were the major lineages of concern up through 2022. And as you can see, each one of them has a slightly different footprint or fingerprint. These are the different mutations that each of them have in the receptor binding domain. So I can just look through and it's like, oh yeah, alpha, beta, gamma, just a game of cataloging. So now I showed this last time, and I'll show it again. This is sort of what happened with wastewater surveillance since the beginning. So we got going, our first sequences came out at the end of 2020. And so by the beginning of 2021, we got this up and running statewide, just in time for the first variant of concern to arrive, which at the time was called the UK variant, and then later was renamed Alpha. And it first appeared in St. Louis. And it was interesting watching it, because we could watch it week to week, and we could sort of see it spreading through the state. And it spread in a very predictable sort of way. It followed the population. So it sort of followed the interstates to the different parts of the state and made to the urban areas. And then after a while, it started fanning out into the rural part. It's kind of how you would expect it. And so this was in March. At this point in time, the alpha variant is all of the green crosses. So we were seeing it all across the state. And if you had looked up at the CDC at that point in time, there had been a grand total of 5 sequences from the entire state, when in fact it was already everywhere. So it just illustrates that patient sequencing got faster for a while, but now it's slow again. So the wastewater really gives you a much faster picture of what's going on. And it's a comprehensive one, because it's showing you the entire sewer shed and just not what patients you might have sampled. So by the end of the alpha, let's see, this was April 2021. If you recall, this is the first time the pandemic was over. Everyone thought it was over. I thought it was over. The numbers were getting really low. There were actual sewer sheds that for the first time were non-detectable. It was mostly alpha variant and a few others, but things were getting really quiet. It was the lowest we had ever seen it. And then something happened. On May 10th, we saw a new lineage appearing in the Branson sewer shed, which is, if you don't know, it's a tourist town, has a lot of country music kind of stuff, air conditioning, indoor singing, really good conditions for a virus to spread. So it appeared, and we looked it up. It was B.1.617.2. There was no alpha, beta, gamma yet at that point. But World Health Organization had said that this was the fastest growing of the India variants, as they were called at the time. But there was nothing. We had seen this here and there in the U.S., but it really hadn't caught fire until this time in May, when in northern Arkansas and Missouri, this lineage finally caught fire in the U.S. By the next week, it had already sort of spread throughout the state. So it moved into both sewer sheds in Branson, and it showed up, and then it started showing up in small towns. It spread in a very different way than the Alpha variant had. And you probably don't remember this, but in May of 2021, there's this Lynn County or Brookfield. This was ground zero in the entire US. If you looked at a map of COVID cases in the US, there was this big red spot in Missouri, which was it was something like 4% of the population got infected over a 1-week period. And we looked at it, and it was all this new lineage, which later turned out to be Delta, but it didn't have the name yet. But within a week, it showed up just about everywhere in the state. But this one was the appearance was almost the reverse of the prior lineages. It was showing up in rural parts of the town. And I really think this was probably because people were taking trips to Branson and bringing it home with them. But it eventually made it everywhere. And then from that summer until Omicron, this is what the map looked like. It was all Delta all the time, and it wreaked some havoc. So here was an interesting thing that we could, and I'll comment on this more later, but we could look at total numbers from the sewer sheds, and we could look at when new lineages first appeared. And what was really interesting was, like with Alpha, we would see it first appear in a sewer shed, and it would displace the other lineages, but it never really caused any major spikes in the total virus, at least not in Missouri. Whereas with Delta, it was just so predictable. We'd see Delta, and within 2 or 3 weeks, it popped, and we would get these huge numbers, and then eventually the cases would follow, and it was a mess. And this was another way of depicting it. This is actually one of the really cool uses of our data that I never expected. There was a data reporter from Time Magazine that reached out, and she was trying to find a way to illustrate to the public what the Delta variant was really doing. But she would try and get more detailed data about, like, how long it takes between when Delta arrives in a location and when you see a spike in cases. But, you can't really easily get below state level data in most places. But with sewer shed is all de-identified. So she could just come in and it's like, look at our data. So she broke it up by county. So what this is every line is a different county. And she normalized it that 0.0 was, by Wastewater, the first date where we detected Delta in that sewer shed. And then the y-axis, the upper part of the line, is showing how many cases were diagnosed in that county with COVID. And without exception, Delta arrived, and within a certain number of days, off it went. There was variability, but it did not track very well with vaccine status or anything else. It seemed, at least at that point in time, that Delta was having a similar output on almost every location. And now moving on to the Omicron lineage. So this is, Omicron really stuck out like a sore thumb. We were also doing surveillance at this point in time from all the sewer sheds from New York City. This is a sample that we collected on November 21st. So this is the week before Thanksgiving. So this is before we collected the sample before the world even knew about Omicron. So we collected the sample. This is about the time that there was that anime conference that you might have heard about, which was the very first cases of Omicron in the US. The first detection from Wastewater was the same time that the first patient was detected, give it a day or two. And those were cases that the first cases were people that they were targeting, ones that they knew had come in from South Africa or places where Omicron was spreading. But there it was in the Wastewater, stuck out like a sore thumb. It had 4 times more mutations than any of the prior circulating lineages. So it took a little while for it to get to Missouri, and it took a different route in. There had been a few cases in Nebraska, which is probably how it got in, because we started seeing it in the northwest corner of the state. It still was mostly Delta, but then Omicron showed up, and it was, again, it spread more like Alpha, though. It kind of followed the population centers, quickly showed up in spreading mostly in the cities, and then eventually making its way out into the rural parts of the state, and eventually was all Omicron all the time, and then all of Omicron sublineages, which were continuing to follow. So this is my last part about this is, what can we do with this information? When do we know that a lineage is going to be a problem? So I just want to point out that for the most part, when you look at where we saw surges, almost all of these have been variant driven. So you see this surge in the summer of July 21st. Well, that very directly and clearly was a result of Delta emerging. It was very clear sewer shed to sewer shed. BA1, same thing. It arrived in December, which led to this massive surge. And then even in this, spring of last year, it wasn't a major surge, but there was a clear uptick, which correlated with the arrival of BA2.12.1 and BA5. And then again, even more minor was with BQ.1.1. But the one exception is Delta. At least in Missouri, and this actually happened a lot of places, there was actually a second surge coming on. Delta was actually surging when Omicron arrived, and it probably would have caused quite a it would have gone differently if it weren't for Omicron. I'll just put it that way. So there are cases like with Delta where there was a second wave that was probably driven by weather and things like that. But for the most part, new waves of infection are driven by the emergence of new lineages. So the question is, can we use wastewater as an unbiased readout that can warn us when when a new wave is about ready to hit? And we've looked at this and we kind of can. So this is all of those different lineages. And one of the things we asked is, how long does it take between when we first detect a lineage and how long does it take to become dominant? We can also look at how long it takes to spread across the state. But most informative is what happens when a lineage arrives. Is there a correlation between the arrival of a lineage and an increase in the total virus? That is actually the most valuable indicator. So spreading across the state, this is interesting. You would think, with all of the lineages that were trouble, they did spread across the state really fast. But that's actually not in and of itself a great indicator, believe it or not, because there have been several cases where a new lineage has moved in and it just appears everywhere, not literally everywhere, but we'll see it multiple parts of the state just really quickly, and then it won't go anywhere. Because I think there are some of these lineages that probably are somehow infecting a subset of the infection, but just seeing how broadly or quickly it spreads is not actually that helpful. Slightly more helpful is how long does it take for a lineage when it arrives to become the dominant lineage in that sewer shed. This is a little better, but this one also has a caveat, which is that when numbers are really low, when SARS-CoV-2 levels are really low, and we go to sequence, it becomes stochastic. And what we're sequencing is probably actually the sequence from just one patient, whoever happened to have a high level the day we sampled. And if it's only from one patient, whatever that patient has is going to be 100% of what we detect. So when the levels are really low, we don't tend to see a big breakdown. So it could give you the false impression that a lineage has become dominant, which may or may not be the case. But in terms of looking for the best indicator, I think it's that what happens once the lineage arrives? Does the arrival of a lineage correspond with an increase in the total viral level? And that is what seems to be the best indicator. So that's what I still do. This is what I was doing earlier today. There's some new lineages moving in. So I look at where the new lineages arrived, and then I go to the data and I say, okay, has there been any change in the RNA that's associated with the sewer sheds where this lineage arrived? And that seems to be the best indicator of what's going to be trouble. Okay, so now the fun part, what's lurking beneath the surface? Ooh, can I go back? Yeah, okay. So let me remind you that the way we do sequencing is slightly different than most places. The way I say it is basically we're doing facial recognition, whereas most places are doing whole body scans, but they aren't doing whole body scans of individual viruses. They're doing it on all of the viruses and then averaging them together. So they know, like, by mutation what is present, but they don't know what mutations go together. So it's really hard by the standard method to tell if there's something new unless they already know about it. So the way we designed it, because I didn't know what was coming, I wanted to be able to tell if there was something new, which was why we designed our sequencing strategy the way we did. And sure enough, shortly after starting our sequencing, just a few months in, we started seeing something that didn't make any sense at all. So this was in early 2021, and there was a sewer shed from St. Louis where most of what we were seeing at that point in time was the alpha variant, or the UK variant, as it was called in the time. It only had 2 mutations in its receptor binding domain, but it was enough to fingerprint it to say, oh, that's what's circulating. So this lower stuff that I've labeled cryptic lineages are the new lineages we started seeing. So each line is a combination of mutations that we were seeing together. And they were totally different than anything we'd ever seen, or really had hardly ever even been seen in patients. They accumulated at 9 different mutations. It appeared every week for about 2 months, and then it disappeared. And it actually was a large part of the total signal. So like sometimes more than 50% of the signal from this sewer shed were these weird lineages that I didn't know where they were coming from. They didn't match anything that had ever been seen in a patient then or since. So it kind of drove me nuts. And I started reaching out to lots of other groups that do wastewater surveillance to see whether others were seeing this kind of thing. And for the most part, they said they don't know because they were doing whole genome sequencing. They're not really geared up to see things that are new. But the exception was in New York City, where they were using a similar kind of strategy where we started working together. And sure enough, so my first question was, is this lineage from St. Louis also in New York? Is this like a lineage that's underlying, is just only infecting a certain population that never gets tested? So we didn't know. But eventually we got a lot of data, and we found by the end of 2021, 10 of these lineages. Most were in New York City. There was one we found in California, and there were 2 in Missouri. And this is where I got into it. I went down, there was a real red herring, which is a lot of these lineages have this one mutation called Q498Y, which at that point in time had never been seen in a patient in any background. But one place we had seen it a lot is when they made rodent adapted versions of SARS-CoV-2. That mutation all by itself allows the virus to be able to infect mouse using mouse ACE2. So I'm like, oh, this is coming from rats. It made total sense. And so I was totally convinced for the longest time then that that's what the source of these lineages were, is from some kind of weird animal reservoir, most likely rats. But there were a few other my initial hypothesis is that it was coming from an animal shelter. But then we would figure out that there's no animal shelters in the sewer sheds. So that didn't really make sense. The next one is the one I like the most is coming from some kind of wild animal, presumably rats. Another possibility is that this was actually like some isolated cohort that doesn't ever travel, like in a nursing home, if they like just kept infecting each other. But the last thing I thought this was coming from is an individual shedder, because a lot of these lineages we were detecting in sewer sheds with 500,000 people. There was just, I couldn't believe that much material could be shed by one person. But spoiler alert, I was wrong. The answer is 4. So this is when I developed my favorite tool from wastewater, even more so than sequencing COVID. My favorite tool is there's a group at Missouri that had developed this technique where they could amplify the ribosomal RNA from any water sample just to figure out what animals are pooping in this water. And it works really well. So this was the first sample I collected. It was from the creek that's in my backyard. This is Hinkson Creek, which flows through Boone County through Columbia. And we did this assay and just looked to see what was there. And there's so many critters whose poop I could find in there. We could find red squirrels, gray squirrels, beavers, cows, dogs, sheep, a whole bunch of different fish, and then a whole bunch of different birds. I'm like, wow, this assay really works. So I thought this is going to settle it for me, because we can go to our sewer sheds where we have cryptic lineages, and I can actually take the same sample and we can see what poops there, and we can figure out what the potential hosts are. And so we did this with New York City, and like with NY3, this is one of the cryptic lineages we had there. This is published. It made sense. There was actually a kind of frightening amount of rat ribosomal RNA in that sewer shed. So I'm like, oh, this makes sense. This really could be the source. But then there were other sewer sheds, also from New York City, also had cryptic lineages very regularly, and we would sample them over and over, and there weren't any rats there. We always saw cat, dog, and rat were the 3 most prominent of the animals. But the other things we always detected are the things we eat. So without exception, we would find chicken, pork, and beef, which is because people eat it and it gets shed that way. But so this was where we were at the end of 2021. We didn't know where these were coming from, and it was driving me crazy. And And that's when Omicron moved in. And it was actually really frustrating at first because I was obsessed with figuring out where these lineages were coming from. And then Omicron moved in. And of course, it was causing lots of problems. But in addition to all the problems it was causing by, infecting and killing people, it was also causing people to shed so much virus into the sewer shed that all of our cryptic lineages disappeared because they were just drowned out by all of the Omicron signal. And in frustration, I decided to design a new amplification strategy, which explicitly does not amplify Omicron. So it sits down on a place of the genome where Omicron has a bunch of mutations so that it can only amplify sequence that was from a lineage before Omicron. And we tried it out and it works so damn well. Like New York, it was like 100% Omicron. And then we would try the new primer set and we amplify it and Omicron disappeared. And all we would see was our cryptic lineages, which were still there. They were just under the surface. We couldn't detect them because they were being drowned out. So once we had this, I'm like, we can actually make some progress with this to figure out how prevalent these things are and maybe figure out where the hell they're coming from. And that's actually when I signed up for Twitter. My colleague in New York, John Dennehy, had a Twitter account. He's like, we should post this on Twitter and see if we can get people to send us wastewater. I'm like, that's a stupid idea, but I'll do it anyway. So I started my Twitter account, and that's when I chose my Twitter handle, which is Solid Evidence, which is just, I'm very proud of that Twitter handle. But so many people sent us their wastewater samples from that one tweet. I couldn't believe it. So we got a really good coverage of the United States and learned a lot more about cryptic lineages and where they are. But the one that was most useful was one from Wisconsin that my collaborator there, Martin Schaefer, who's is in charge of the wastewater testing facility there. And they're also a really great organization. They do great wastewater testing. He sent me a bunch of samples, and one of them had this really interesting lineage in it. It had as many mutations in it as Omicron did, but it was totally different mutations. And so he sent us more samples to see how prevalent it was, and we could detect it every darn week. And this is in a large sewer shed. And I'm like, we could maybe track this guy and figure out what animal it's coming from, because remember, I still believed that it was coming from an animal. And so we started to track it down. We started to do our ribosomal RNA to figure out what the candidates were. One of the candidates was, once again, dogs were showing up in the wastewater. And so we're like, oh, dogs. And so this is a picture of some of my collaborators in Wisconsin going to the local dog park and collecting water samples there, as well as going to the occupants and collecting the feces from their dogs and sending them to me to look for COVID. That's in addition to, I don't know how many hundreds of rat turds that were sent to me from New York that were all COVID negative. So yeah, we were trying to find the source. It had to be coming from somewhere. And then we're like, okay, well, let's try and track it. And so this particular wastewater treatment plant had 6 main lines that went into the main plant. And so we tested them all, and only one had the lineage. And then that one was fed by multiple substations, and we tested them all. And once again, they were all, only one of them was positive for this weird lineage. And then we worked our way up, first through 17 manholes within the city, and then we got to the village, and we went through another 21 manholes, again, just figuring out, okay, where is this lineage coming from? And we finally narrowed it down to a single manhole. And we thought going into this, we were going to find an animal shelter or a nursing home. We get to this manhole, there's only one thing that contributes at this manhole, and it was a company. Just a company, 30 employees, serves the public. It didn't make any sense. So the Department of Health was leading everything at this point, along with the CDC, and they went to the company and said, okay, it seems somehow the signal is coming from here. It's probably someone in your company. Could we test them to see if any of them have a persistent COVID infection that maybe you're not aware of? And the company came back and said, sure, you can do that, but first, can we figure out which toilets it came from? So they had 2 sets of toilets in their facility, one that was only used by employees and the other one was used by the general public sometimes, people who were coming in to do business there. And so we tested them both, and it was only in the one that was used by their employees. But this is where everything turned around for me, because they sent me this sample to see whether that it was there. And oh my God, I had never seen so much COVID in a wastewater sample in all of the time I've been doing this. It was 1,000 times higher than anything I'd ever seen before. There was so much virus there that we could detect it with, I mean, this is, I don't know how much, it was a composite wastewater sample over a 24-hour period, and I could take 2 drops and detect the virus with a rapid antigen test. It was insane. And this is when I realized that everything I had assumed was wrong, that there are people with persistent infections that shed 1,000 times more virus than a typical acute infection. And that is what's leading to these weird cryptic lineages that we're detecting. So to wrap up the Wisconsin story, which unfortunately, well, I don't know, it doesn't come with a satisfying end. We never found the patient. They did communicate with the employees about what was going on, and offered free nasal testing. About 2/3 were tested by nasal pharyngeal swab, and they were all negative. So either the infection was not in the nasal cavity, or the person that was infected did not get tested. We don't know which, but that was sort of, at that point, the health department is like, this is no longer public health. This is research. You need to get an IRB. So we got an IRB, but that took a long time. And 4 months later, before we managed to go in to do patient testing, the signal disappeared. I don't know whether the person took a different job, or I don't think they died, or maybe they went into remission. I'm not sure, but the IRB was eventually approved, and we went ahead and I've actually now been to this company. I've met with the employees. None of them looked obvious to me as the carrier. I got a selfie with the manhole that we tracked it down to, but all of the stool samples we've collected have so far been negative. So I don't know if the story is over or not, but it was very valuable because it taught me that that there are very, very long persistent infections in patients that are the source of these weird lineages. And I think these are things that we should be caring about. This is an illustration of something we keep trying to find a good way to illustrate it, but the mutations that we see in our cryptic lineages, they are forecasting the lineages in these persistent infections are basically evolving on the fast forward button. They're picking up the same mutations that eventually are found by circulating lineages. So this is just a few examples of some mutations, like N460K was in the Wisconsin lineage out of the starting gate. That mutation had never been really seen in patients at that point, at least not in any circulating lineages. But then in the end of July of 2022, the Omicrons found it. And now pretty much 100% of sequences in the world have this very same mutation. Same with a bunch more of them. Here's another, now here's the rest of the story with the Omicron lineage. When the Omicron was first announced, when they first mentioned it, it was just before Thanksgiving in 2021. And I was with my family driving up to Chicago for Thanksgiving, and my colleagues in New York wrote to me, it's like, did you hear about this? And they sent me the sequence, and I was staring at it. We were all staring at it, and we were going through mutation by mutation. Every single one of these mutations we had seen in a cryptic lineage before, but we were trying to remember, is this one of ours? We knew our lineages at that point. They were very reproducible, and we eventually figured out, no, this is not one of ours. This is not one of our cryptic lineages, but it has the same mutations we had already seen, but just a new combination. So that's led me on the search of lots of more of these. In addition to getting samples from all over the place, we can also just go into public databases of other groups that have done wastewater sequencing and upload it into a public server. And once you know what to look for, you can find that these guys are all around. I need to update this slide because there's now 43 cryptic lineages. I found 3 this week. It's crazy. They're still around, and most of them are very old. So here's an example of one that you might have heard about. I took a slightly different tact with this one. So I was going through the public database, and we found this really unique cryptic lineage from Ohio. And I'm like, that's really interesting. And so we made a specific search to look for other sewer sheds that might have this combination of mutation. We went through all of the sewer sheds in the United States, and we found that it was somewhere else. it showed up in a second sewer shed. All we knew initially is it was also in Ohio, and we eventually figured out it was a small town 40 miles away, and it was present exactly the same days in both locations. So it's pretty clearly someone who either lives in Columbus, Ohio, and commutes to Washington courthouse, or vice versa, or for some reason zigzags between the two. I forgot to mention this, but the Wisconsin lineage, we know now that it was derived from a lineage that was circulating in late 2020. So whoever that person was, they were infected for about 2 years when we were detecting them. Same thing with Columbus. It was this person has been infected for over 2 years. It is a highly divergent lineage. And I should mention that, like, in Washington courthouse, like in May of this year, they were seeing the highest levels of COVID in their wastewater they have seen to date in the pandemic. And when we did the sequencing, it was entirely from this one person. So there are cases where these lineages can really throw off the numbers. So one of the useful things we've gained from these lineages is that we can look at, like I said, that there are mutations that appeared in Omicron that we had seen before. The SARS-CoV-2 is highly convergent in terms of finding mutations that are of an advantage. And we started going through all of our cryptic lineages to look for mutations in common. And the most common one we found that is not generally circulating is this one 977Q. And it actually is, it turns out a group already figured out what this mutation does. It stood out because this is one of the amino acid changes that is different between SARS-1 and SARS-2. So when you go from K to Q, you actually go back to the SARS-1 sequence. And so this domain of this protein is actually a protease. It cleaves other proteases. And if I can go into the weeds for just a second, I anthropomorphize too much, but this is the virus has this really clever strategy. So this is a protease that cleaves the polyprotein at the first 3 sites. And those sites are different. And the sequence where the protease cleaves is exactly the same sequence that's at the C terminus of these little proteins called ubiquitin, which is this thing that the cell uses for signaling. And we now know that this mutation greatly enhances the protein's ability to cleave polyubiquitin chains. So what this does for the virus is often polyubiquitination is how it triggers the innate immune system that there is something wrong, that triggers the innate immune response. So this mutation is part of a silencing mechanism. It helps the virus hide the fact that the cell is infected. So you might wonder, why is this not in all of the circulating lineages? And I don't know. It has appeared a few times, and I'll talk more about that in a second. But I think this might be one of those cases where what is an advantage in a chronic infection may be a disadvantage in a circulating lineage. So my best guess is that if a virus is infecting you, and it's not going to make it. I mean, your immune system is going to kick its butt in 5 to 7 days. So it's got this short time window in which it can circulate and then spread to someone else. And I'm guessing that there is a sweet spot in terms of how much of an immune response the virus wants. It probably wants you to be at least partially symptomatic, so you're coughing, sneezing, all that stuff. But that's my best explanation for why we see this mostly in persistent infections, but not in those that are shedding. So I'm not the only person that looks at chronic infections. There have been several papers, but here is a really elegant one that came out very recently from the Mount Sinai group in New York City. They actually had a really big data set on patients that were part of their whole Mount Sinai hospital system. And they found this set of lineages that it actually one that started out in one patient and ultimately led to 4 different patients. But the virus did the same kind of thing. It went on evolutionarily, fast wire in terms of evolution. And sure enough, midway through this long infection, it picks up this exact same mutation that I was just mentioning, this 977Q. But what's interesting about this one, so I remember these are persistent infections. And although this did not become widespread, it was infecting new people. It isn't, persistent infections are not necessarily non-spreading. This is an example of where it can start spreading again. So one of the things we could do then is we could start using this information about what is probably a persistent infection to look at How many persistent infections are there? How many of the sequences in the database are people that were actually persistent infections and they might not have known it? So this is really interesting. What I'm showing here is all of the sequences that appeared in the database, which were BA1, the original Omicron lineage. It was a very clean thing because it took over. It was absolutely everything, and then it disappeared almost as fast as it was displaced. So if you look in the database of whether there are any BA1 lineages that have this 977Q mutation, what's really interesting is you hardly see any of them when BA1 was circulating. But after it was circulating, you start seeing them pop up, and they pop up every in a sort of regular clip, and they're continuing to pop up today. You'll still occasionally find BA1 sequences from patients that were just sampled. That the case I just mentioned, this was a BA1 derivative that was, it continued persisting in these patients for years after. So you can tell that, okay, this is actually a good indicator because these are all presumably BA1 persistent infections. But there was one that stood out that didn't make any sense, that there was this one Omicron lineage, which was BS1, that had the same mutation, but it was actually circulating. There was like 600 patients. And so I dug a little deeper into this, and it was really quite interesting. So the BS1 is also BA2321. So it's derived from BA232. And the first place that this BS1 appeared was in Vietnam. And so what I'm showing here is how much there was of these two lineages in Vietnam. So in blue, these are all the 232. These are all the parent sequences. The parent basically disappeared. And then at the very end, this other one appeared, the BS1. And what was interesting is when it first appeared, it had already picked up 38 nucleotide changes. This was not a virus that had been circulating. I guarantee you what happened was there was a patient that was infected with BS1 or with the 232, and it was a persistent infection for multiple months. And then what happened later in the year is that it started circulating again. This one, it had several mutations that gave it an advantage. It ultimately was drowned out by the XBBs, which also had a lot of advantageous changes. But it again shows that these persistent infections that start picking up a lot of mutations, they are sources of new lineages. So one of the things, so what I've tried to do is also the reverse. I wanted to ask, how often do persistent infections have this mutation? And so if we use, I've done a set with this with several ones. So if I look at sequences that I believe have to be persistent infections, so if I look for BA1s that appeared after BA1 was completely gone, and then I say, how many of those have the K9070 or the 977Q? It's about 5%. Whereas when it was actually circulating, it was 0.002%. So there's clearly a thing. It's more commonly found in persistent infections, but it's not found in every persistent infection. But I can use this to sort of do some reverse checking to look back at how often do we see this mutation? And if we assume that it's 5%, you come to the conclusion that about 0.2% of the sequences in the database are actually persistent infections, or about 1 in 500. And here's the thing. We don't really know who these patients are. You usually can't track them down. I've tried, believe me. We have no idea what their symptoms are, and we have no idea what the long-term impact is. I mean, the question that really drives me is how much of long COVID is actually persistent infections in parts of the body where we're not checking. We know from autopsy studies that there are cases of circulation in the heart, in the GI tract, and lots of other places, but it's hard to get a gauge on whether the virus is still replicating there and causing problems. And I just like to mention here that there is a precedent for this kind of thing, which is with domestic cats. There's another coronavirus called feline coronavirus. It's not a Sarbeco, but it has a lot of things in common. It also has a furin cleavage site, but it infects the GI tract. And when it infects cats, some of them clear it, but some of them have a persistent infection that lasts for years. And this isn't necessarily in immune compromised cats. The best indicator of whether a cat has feline coronavirus is whether it's lived with a lot of other cats. And most of the time it's asymptomatic, but about 5% of the time it progresses to a new tropism called feline infectious peritonitis, which is pretty much always lethal unless you treat them with COVID drugs. And so here's just some of the patients we've found just going through databases. There are some pretty out there ones. The most diverse ones we found are still from wastewater, but there are some pretty darn diverse ones we have found. Just like there's this one from Indonesia that was submitted last month. It's a delta derivative. I tried reaching out to them to find out anything I could, and they pulled their sequence off of GIS8 and won't respond to my emails. It's kind of frustrating, but there's sort of a catch-22. It's hard to find out information about these patients when we don't have evidence whether this is hurting them or not, but it's hard to find out whether it's hurting them or not unless you find out about the patient. So that's my current circle of frustration, but we're making progress. There's a lot of groups that are starting to appreciate that persistent infections are something that deserve our attention, both because of the threat to the patient, but also for the broader population, because this is where, if there is a pie, the Greek letter that comes after Omicron, I guarantee you this is where it will come from, as a persistent infection. So this is my summary. Yeah, cryptic lineages are persistent infections of people that are shedding a ton of virus. They almost always have an incubation period between when we first, so like there's always a lag between when a lineage is circulating and when we start seeing cryptic lineages, because it seems to have to go through certain things in the body before it can become these massive shedders. And I'm sure we are missing a lot. We don't know what the symptoms of these patients are. I'm guessing they're GI infections, but I don't know that. And we don't know what the connection is to long COVID. But I guarantee you what we're seeing is the tip of the iceberg. We only find, so we're up to 43 cryptic lineages. These are only when there is a persistent infection. They have a lot of changes. They're shedding a ton of material, and it happens to be in a sewer shed where I have coverage and the data is publicly available. I'm sure there are tons more that this is part of the next wave. It's knowing what's happening with these patients. This is an enormous collaboration, and I have 1,000 people to thank, but I think my time is up, so I'd be happy to take questions.
Thank you so much for that, Dr. Johnson. You were actually right on time.
Oh, good.
Right on time. So no problem there. Now, what we're going to do is we're going to deal with the questions in the actual chat. And I know that Faraz, you have your hand up. So do you want to intervene a little bit, Faraz? And Rob's going to be also pitching you some questions. Thank you so much for this presentation. Okay, nope, sorry. All right. Dr. Rob Wallace, why don't you give our friend here from Missouri some questions? And I really appreciate your work. And I don't know about you, but your friends do tend to send you poop, and I'm a little worried about that, Mark.
Yeah. This is not an open invitation, everybody. Okay, don't just send poop
Send me
in
your
the envelope.
Well, this is a
a wonderful presentation, and we have like 35 questions. I don't think we'll be able to get them to all of them, but we did block out a half hour to throw some at you, and they're all over the place. I'm going to try to send them to you in a kind of order of the work that you're doing. So I'm going to start off with the first one, because when you presented to us in-house a few months ago, I think you did address this. One attendee asked if there is time. Okay, I'd like to hear more detail about how wastewater analysis is conducted, or if there are resources we could review independently that have a good explainer. That would be great. Thanks. So
do you have our sewer shed surveillance project is actually a story map which explains the whole process if they want to go there. Do you have the website? I can grab it if you want.
Yes, we'll post that up in short order. So
there's several sites now to get information. The news site NWSS. So if you Google NWSS CDC, that will take you to a site that has national data. It's not as fine detailed as a lot of the states. BioBot also has a really good dashboard. SCAN has a good dashboard, and a lot of states have their own individual. So Missouri has Missouri data is all transferred to CDC, so you will see the news data on their website from Missouri, but there's a lot more detail on the Missouri site, because we'll drag it down to exactly what lineages are on each sewer shed in the state and what's moving in and all that stuff.
Okay, and so those sites will explain the actual testing process of gathering the samples and how do you amplify the RNA and all that. Is that correct?
Yeah, if you look at the Missouri story map, and if you still have questions, email me.
Okay, fantastic. So here's another question. I think maybe it has to do with, the graphs seeing over time, the change. Will you please explain how to read and interpret wastewater data graphs?
Well, let's see. Let me share my, oh, where'd you go? I was going to share screen again. I lost you. Zoom. Share screen. I assume you mean just the surveillance, the numbers? Or are you talking about the?
I
Sorry,
think some sort of time series where you
like
see
this one?
in a particular, yes.
So the y-axis is just, for this one, this is the state cumulative. So just pay attention to the orange line. This is the cumulative amount of SARS-CoV-2 in the state. So for each sewer shed, we measure how much virus is in each quarter cup. We multiply that by the total sewer shed volume, and then we add up all of the sewer sheds from the state. So this is the total copies of RNA that we detected for the whole state. So the higher it goes, that means that's how much, that means more virus was being shed during that time period. So y-axis is just amount of RNA, x-axis is the date of collection. Does that help?
Yeah, I'm just gonna continue to throw as many questions as we can. We're up to 40 questions now. And looking at watershed data in my area, someone asks, how can I read it to best assess current COVID risk? What are the benchmarks to consider?
The best thing is to look at each sewer shed compared to itself. So the best thing is to look at that sewer shed over time, and don't say how high is my number compared to Boston. Say how high is my number now compared to where it was this spring or last summer, or compare it to when you know things were bad. And if they're the same place, then that's when you want to be concerned. If they're much lower than that, it's corresponding less. Numbers nationwide are still on the low end now, but not as low as they were a few months ago.
So it's county by county or city by city. Here's another question. Post recently said that sewer only detects approximately half of total cases. What is your opinion, and how should that issue, if true, impact interpretation of sewage data? I'm asking for a link to the source, but don't know if it will be obtained by the end of the conference. Okay. Also, this is gross, but I heard a long time ago that fecal can be a source for COVID testing, for example, in pets, which I think you covered.
Yeah, I've actually encouraged people, if they think they have long COVID, to go ahead and try a rapid antigen test, because it's usually there's only one lab I know of in the States that will test stool, and most doctors won't send a test there. But if they find out for themselves, just don't use too much material. You just dip it in the water, in your toilet water, and use it. Okay, so the thing about 50%, I don't know. That could mean one of two things. It could mean either that only 50% of the population is covered, which is probably about accurate, because you can't get everyone. There's a lot of really small sewer sheds and a lot of people on septic, but the virus, if I've learned anything, is it does not stand still. And if it's happening in here, it's probably happening 10 miles down the road. I mean, Delta swept Missouri in 2 weeks. It doesn't stay put. The other thing, what they might be talking about is that not everyone seems to shed in their stool. The data is not entirely clear on this. And it's not even clear for sure whether what we're detecting is because of GI infections or because of nasal snot that makes it through your gut and we detect it. So it's not every patient, but I can tell you it is, on a population scale, it is still very representative.
Yeah, I think a lot of questions here speak to this issue of whether or not COVID persists in everybody. Is it cleared from most people? It's fully cleared in some, or what's the usual clearance time? And it sounds like what you're doing is at the population level that allows you to make kind of certain generalities, with even those conditional on what variant is around and what watersheds you're looking at.
Yeah, I mean, there is variation, but it is generally very representative of what's going on in the population. And so sometimes there will be lots of infections and not that much RNA. That probably means there's a lot of mild infections. It's not a one-to-one thing, but it is reflective of the amount of virus circulating in a population.
Right. And for good reason. A lot of the questions are fascinated by the long haulers. I mean, the fact that how you were able to identify one's a magnificent detective work there. So one question that's kind of representative of this is, do you know if someone is infected for years with a cryptic lineage, are they contagious during this time and longer?
I don't think they are. And the reason I say that is because if they were contagious, they would infect other people. If they were infecting other people, it would not remain geographically constrained. So far, none of the cryptics that I have been following have escaped, but I gave you a few examples of where escape has occurred. So it's not that it can't happen, but it's probably not easy. So my suspicion is that these really extreme cases are probably GI infections. And for whatever reason, so first of all, it's probably nearly impossible to get infected with COVID from wastewater or from stool. The virus, we've tried culturing it, even from that sample from Wisconsin that was just through the roof high, we could not culture virus out of it. It seems to not live very long in the GI environment. So by the time it's excreted, it's non-infectious. So I don't think it's easy for it to spread because of that. That said, I think the virus, if the patient is doing bad enough, the virus will become systemic and probably will reseed parts where it can spread. I mean, think of it like late-term HIV infections where it just goes crazy. So, I mean, they're all potentially going to be contagious, but there's no evidence that any of the ones I have reported are currently contagious.
Right. So the person who was asking about the possible danger of environmental exposure from sewage can rest easy. That's not going to be
there was some weird reports from China about sewer, but I mean, I can just say that from our own work, it's pretty much dead. What's in waste.
Right.
And there's been lots of groups that also have done this with animal studies and in other studies. And there's only a handful that were ever able to recover it, even from fresh stool samples.
Right. Okay, so here's another methodological question. It says, at what, or even an ethical aspect to it, at what level catchment do you start to question anonymity of the sample? What conversations were taking place when discussing how far upstream to move the sample collection?
Yeah, that's a great question. And this is something that really needs to be decided by more than just me and my colleagues. In general, we don't. So with Missouri, we don't report anything that's smaller than 1,000 people. I'm pretty sure that's correct. I mean, that's where we start getting really cautious. In terms of when we were tracking the lineage in Wisconsin, keep in mind when we were tracking, it wasn't until the very end that we even realized we were tracking a person. We thought we were tracking an animal. So at what point and that's a great question, when someone flushes the toilet, when does it become public where you can where it's no longer yours to claim? I mean, if it's like garbage, the moment you put it on the curb, the cops can legally come by and go through and see. I mean, in terms of like legality, there's a difference between, of course, what's legal and what's ethical. And I guess the answer is I don't know. And I think this is a conversation that needs to be had by more people than just me. We need to include ethicists, bioethicists. I will say with Ohio, I was public about that, but I did not narrow it down to, a lot of people were saying I doxed the person, but you couldn't narrow it down to less than 1,600 people because there's a lot of people that move between those two locations.
Right, there's the element of trust being an epidemiological variable that has to be included in all this, and certainly we don't want people to become so distrustful that they refuse to use the bathroom anymore and decide to go out in the backyard. So the public health, so to speak, don't grab onto it. But
it's a tough one because though at the same time, if it I mean, I don't know what the outcome is, but if it really is something that could kill the person, and
Right.
it's treatable and they don't even know they're infected, most people would rather know, especially if they can, get, treatment and cure it. It's not like HIV. It's not like something that is, you can't do anything. There are treatments and there will be more treatments down the road.
All right. So here's a question about where we are presently, and it kind of connects to the Stanford University study that came out in February, basically saying that the link between the wastewater and the cases were actually the signal was best when your sample is at 50% or more going back to December 2021 in terms of the samples, and that link actually declined over time through 2022. There was a disconnect between wastewater and the caseloads there, and everything from all the rapid tests being done, and so the caseloads aren't representing that anymore. But this question gets at perhaps another possibility. Given that you believe that less RNA is being expelled per case as people are being vaccinated or getting more protection from natural infection, has the method of calculating projected case counts changed to reflect that? How much has the RNA been reduced per case? Is it half as much, 25% as much?
Yeah, I don't know. So in Missouri, we do not project case numbers. I had my formula that I would, tell my friends if they asked me, but it's not something we said publicly because we knew that we didn't really know. It's like saying, how much does a person weigh? It depends. But in terms of how much is it reducing, that's a really hard one to get a handle on now because the testing is so bad. The only way we could really know that is if we have situations where we do still have good testing and can do the correlation. But yeah, I don't know. I can only say the disconnect for us started about at the beginning of 2023. That's when the case RNA totally disconnected. But before then, it was just, it wasn't like an all or nothing. It was just a slow reduction with each new wave in terms of how much RNA was being shed.
Yeah, there's an aspect of this doesn't necessarily have to be a zero-sum game. It's not that wastewater can replace caseloads. It's that the fact that we've stopped collecting caseloads is a damaging event and circumstance, and that if we did have caseloads at the various levels, then the wastewater could actually fold in together with that in a way that would benefit public health overall. So
yeah, I mean, even if we can't, I mean, this will always be a shortcoming. We can't say how many cases there were, but we can tell if things are going in the wrong direction. I mean, when we see more RNA, we don't know whether it's a lot of asymptomatic people or a few people that are really sick, but we know that that someone's being infected somehow and we can tell whether it's going in the wrong direction.
All right. So we have some more technical questions. I think we'll circle back to them, but with making sure, I mean, we do have some time. We're just about halfway through of questions, and then we've got plenty more for you. But I do want to get to these two questions, and they have to do with the, given the applicability of wastewater surveillance. They had questions about what can members of the public do to help support continued wastewater surveillance? What would be effective? What do you need? Thanks so much for your amazing work. And then the second question is, how are you currently funding the program? How do you expect to fund it for the next 2 years? I guess there was also another question about perhaps that funding is perhaps on chopping block as much as some of the other COVID surveillance methods.
Actually, so there is some attrition. There are wastewater operators they're dropping out, but the good thing is it's sort of reversed. In the beginning, it was easy to get wastewater operators to sign up, but it was hard to get the health officials to believe the data meant anything. It's reversed now. So we've proven that this is a good tool for giving you a big picture of, it's not a crystal ball, but it's a reality check of what's going on. And the CDC and the health departments and the decision makers have totally bought in. It's when groups are dropping out now, it's because the wastewater treatment operators are just sick of they feel like the pandemic's over and they're tired of sending us their samples every week. But there's not that much. So the news program has extended their funding for 2 more years, and they're adding a whole bunch of more things to what we'll be surveying for. One of the big ones that is a whole bunch of antibiotic resistant bugs we hope to start being able to search for.
Right.
I feel like there was a part of this question I didn't answer.
Government support, funding. I mean, you spoke to the reverse, that the public health department seemed to be in favor of it. But given that COVID money may be in decline, will that money be available, or will it be repackaged as a kind of a more general method of infectious disease surveillance? Or
in the US, the wastewater monitoring is probably the cheapest part of COVID work, and it's also the part that has the most support to keep going. I think enough people have realized that you get a lot more bang for your buck with it, and that way you don't stop everything, but it's enough to keep your eye on it.
And
I'm pretty optimistic, at least on that side of things.
Right. So there's also a lot of room to grow, right? So you've got CDC reporting 1,600 plants every couple of weeks, and there, as I understand it, something like 16,000 public wastewater surveillance plants. So if this is expanded beyond COVID to other pathogens, this could be a major national new surveillance method by which disease could be tracked.
Well, and you don't have to limit yourself to pathogens. We can also detect. We measure caffeine every week as a measure of whether the wastewater has been diluted or not. You can measure illicit drugs. You can measure opioid levels. So you can tell with a population how much opioids there are, but also what kind. Is most of the opioid consumption from prescription, or is it from illegal import? And then it allows public health to potentially target their efforts where they're needed most and have a readout for whether their efforts are actually helping. But it's not just with pathogens. But, once we get into those other things, there's a whole other conversation that needs to happen with, everyone's got to buy into this. There's going to be a place where it's like, don't go that. No, that's too much. Stop. And that's fine.
Right. So there is still the problem we had of the vaccination level of gaining the people's trust enough to be able to buy into public health as a concept, much less as a method. And unfortunately, coming out of our, at least the view over here is that coming out of a major pandemic, one would hope there would be greater respect and understanding of public health, and instead we have something going on in the reverse. And so tracking down people's poop, even with all the public health applications, as you were getting at earlier, requires reframing and reset on the role of public health.
Yeah.
All right, let me look some more questions here.
Meanwhile, let me just ask Mark. So those folks who are like civilians, non-scientists, what do we need to do? Do we need to,
That's what
write to our? Yeah. I mean, what do we need to write to people? Like, let's say someone's in Missouri, in your state, and they like your work. What do you tell them to do to keep it funded and to keep it out there in the public domain?
Well, all the testing is done by public servants that respond to the desires of the public. If you want this, you have to let them know that. If your, community stops doing wastewater testing, go to city council and say, this is stupid. We want this back. They tend to be very responsive to that. Often when places do drop off, it's because there's a disconnect between the people that are collecting the samples and the ones that are digesting and utilizing the data. And if you let them know that this is important, then usually they're perfectly happy to keep doing it, as long as there's funding to pay for it.
That's great. And I one of the things there's many things I'm going to take away, but one of them is this notion of the two things we need to watch now, given the dearth of some data that's been sort of, not done anymore: hospitalization and wastewater. right? Those are the two things we need to watch out. And also, I was looking at a newspaper article where they talked about the FG variant, and they were sort of worrying about it. What's your it's FG? I think it was like
EG.
EG.
Oh, so
I'm
yeah,
ahead.
EG5 is yeah, it's making some headway. It might be part of the reason we're seeing increases, but it's not a game changer. There's already some EG derivatives that I'm watching more closely, or there's yeah, FL and HV. There's a few. I mean, it's hard to know which are going to be trouble until they are, but there's already some EG subderivatives that I'm pretty sure will overtake it, but none of them are game changers at this point that I've seen. It might take a combination of waning immunity and changes in environment before we see another wave, unless there's something entirely new, and then all bets are off. I mean, I think pi is still out there. I think we will see another major wave at some point, but
So
I'm
you,
wrong all the time, so don't take it to the bank.
all right. So you're adhering to more of you're swaying more optimistic, at least for the short term. But then there's also the issue of that any new variant that shows up in the wastewater doesn't necessarily mean whether or not it's going to be virulent.
Yeah, we watch it every week. We look to
Right.
see whether when there's a spike, whether it correlates with some new variant. And we like with BA.4/5 wave last summer, it wasn't as obvious as it was with the earlier ones, but I mean, like with Delta and BA.1, I mean, it's not hard. In a week that this is trouble. I haven't seen anything like that since in a year and a half.
Yeah, I would take that as good news. Fingers crossed.
You can die even if it's not a major wave, though. I mean, there's still infections. I mean, I will say that.
Right.
I mean, this is amazing, but there is basically no sewer shed in our state that's negative. They all have some. It's low, but it's still there.
Right. And of course, there's the disconnect between the damage in the acute phase of the infection, the first infected, to the long COVID stuff, which seems to be still on track. So let's do some more questions, if that's all right. How can LHD epidemiologists, and to my embarrassment, I don't know what LHD means. How can LHD epidemiologists or clinical hospital data analysts help with these efforts?
If they want the data, we'll keep providing it. That's the best I can say. I think it's probably the best source of information. I mean, along with hospitalizations, like I mentioned, those are, in my opinion, are the best metrics of what's going on. It's, use it or lose it. If you use the data, it will continue to be there.
Right. So I think your example of what happened with sequencing is a good example of that. I mean, the U.S. was a major center in genomic sequencing, at least what to do with it and all the analyses. But as it is applied to public health, it kind of went by the wayside, which was unfortunate. So one can see the kind of combo of wastewater surveillance, hospital surveillance with COVID cases, and with genomic sequence, having those three things talk to each other so that each one can help fill in for what the other ones can't do. And then we start moving into a world of a 21st century public health rather than stripping those things back.
Yeah. I mean, wastewater is never going to replace patient diagnostics and sort of what it can do is it can give you the big picture, and it can give it to you pretty fast. I mean, I think this will eventually become more of a thing with the influenza, that we can give a rapid readout of whether the vaccine is going to work this year.
Right. So this gets into another question here, and that speaks along these lines. Would more comprehensive general testing and contact tracing have helped you identify individual patients?
Probably not, actually, because they were infected 2 years ago.
Right.
With a lot of other things, it could still be useful, but for specifically for the persistent infections, probably not.
Well, suppose you had a new variant that emerged that had signs and signals of a amino acid replacement that was dangerous. Could you then go to that wastewater and with the local public health department do some contact tracing enough to maybe find that person or that small group before it went?
Oh, that would be actually, if there were like a persistent infection that then started spreading, it would be interesting if you could go back and figure out for sure what was the source.
Yeah,
Then that gets into ethical quagmires, so I'm not
right.
sure whether you would do that or not. It would be, from a scientific point of view, it would be very interesting. I'm sure, I mean, well, most of us think Omicron came from a chronic infection, but
Right.
I doubt the person would want it to be known that they were the source of Omicron. If
Well,
there's-
nobody wants, yeah, you don't want them be known as patient zero or anything. So the ethical aspects are critical here.
Yeah.
Let's see. So, but it does link to something that was, I think, unfortunately, some of our colleagues at the CDC may have missed on this, is that the focus was on, say, keeping people quarantined for 5 days instead of 10 days, right? Even though the molecular kinetics are showing that people are infectious, or at least a goodly proportion of people are infectious, even 14 days out. So at the population level here, you have folk with chronic infections. Don't know if they're infectious. I think you said that they are probably not. But ostensibly, if you still have people walking around still generating infection, and if we've basically, very much limited our capacity to engage in quarantine and such, then it's the tail end folk that are capable of keeping the lineage or lines of infection continuing.
Yeah. Although the stuff you're talking about goes beyond what it's not my expertise. You have Michael Mina on sometime to talk about this stuff. He's, when are people infectious, and what is if you're really using the data, what should the recommendations be? There are a lot of smart people that can answer that question a lot better than I can.
Okay, so I guess in this that line, and I don't mean to follow up with another question that may not speak to it, but another one from our YouTube channel is, I'd still like to know how he knows these people aren't immunocompromised if he doesn't know who these patients are and can't test them or know their medical history.
Oh, I don't know that they're not immunocompromised. I'm just not assuming it. I'm not taking it for granted. Actually, there's a very good, I think it's very likely that they are somehow immunocompromised, but it might not be the obvious things that you think of. It could be some defect in some gene in the innate immune response that you don't even know you have unless something like this happens. I think there's something about these people that allows the persistent infection. I'm not, especially because of the stuff with the cats. I'm not just assuming that they're going to be your caricature, your obvious example of an immune compromise. I don't think there's any reason to limit ourselves to that.
All right. So we're getting down to it, but here's a question that often ends a show. So I thought this is a good way, and it just popped up now. Someone asked, what keeps you up at night? And I think they're referring to COVID. We don't need to know your personal business, sir.
Okay, so not too much coffee. I lost a lot of sleep in 2021. I sleep pretty well now. I think we're going to get through this. The thing that scares me most is the backlash. It's not actually the virus, but it's the stuff you're talking about, the backlash against public health, against it's over now, and now we distrust the people that are trying to help us. That's the part that scares me the most, because it could get really bad. And it's always, I hate it when it's one step up and two steps back, and I hope it doesn't come to that, but that's the thing I worry about the most, I think.
But in the short term, there is if I may summarize what you said in terms of your recent surveillance? There's nothing that's arriving that is worrisome about in terms of a new variant that might lead to a new spike. EG5 seems to be within the boundaries of what you've seen before. Is that a fair summary?
It might be. It could be a 4 or 5 level spike like what we had last summer, but I don't see anything that's like the BA1 original or the Delta. Those are the two really big ones in Missouri. There are a few other places where other lineages had major impact, but you know what a major hit is when you have it because your hospitals are full. I haven't seen anything like that on the immediate horizon.
Would you it'd be fair to say as we wrap up that the pandemic though is still ongoing?
Oh yeah, this virus is never going away. Whether we call it a pandemic or endemic is just nomenclature. But the virus is going to be here forever. And we'll learn to deal with it. It'd be nice, we're better equipped to deal with these kind of things than we've ever been in the past. But getting back to your question, it's like, will we have the common sense to actually utilize the tools we now have or not?
Okay, thank you very much.
That's some plain speaking. That's some Missouri plain speaking there at the end, Dr. Johnson. First of all, thank you so much. Our team, of course, Rob and Faraz and Kinsey, but thank you, Mark, for sharing your time with us and just keep on doing the science, brother, because we need it. And you're right. We need to be very aware of the backlash. And folks, you can join us. You can join the People's CDC. You can go on to Dr. Johnson's website. You can be part of the solution as well. And I'm going to end today because we're going to be ending and doing some music soon. Rob, I'm going to give you the last word, and then we're going to do a little quote and then do some music. Rob, last word.
All I have to say is just thank you, Dr. Johnson, for your work. We really appreciate it. You've been very open with the public about the work you're doing, your website on the surveillance project. If we don't post it here, we'll certainly post it in the video description. It's fantastic. I think if only all the states across the U.S. had what Missouri has now, we'd be in a much better position. So that's all I have to say. My deep appreciation.
Thank you.
And I'm going to quote from this book, To Speak a Divine Word, which is the writings of someone named Pauline Murray, who was way ahead of her times. Reverend Dr. Pauline Murray was also schooled Ruth Bader Ginsburg, taught her how to do some of the law. And she wrote, "I have never been able to accept what I believe to be an injustice. Perhaps it is because of this I am America's problem child and will continue to be. Let's continue to be the CDC's problem child and doing the thing we need to do." Thank you, Mark. Thank you, everybody. Faraz, a little music as we go out. And thank you, comrades, for coming. We had a lot of people up in here, and that's a good sign. Keep the faith.
Thanks.